Take a look at this limit here. And the limit as x approaches 1. We have this expression here involves the difference of two fractional expressions. I went ahead on this one here and factored that to sort of guide us where we're going to go here in a little bit, but this factors is x minus 1 times x plus 10, this denominator here. If I try and see what is happening to these expressions as x approaches 1, well, from the positive side, if we're approaching 1 from above, like 1.1, 1.01, and so on, this first fraction, of course, we're getting closer to 1 divided by 0, right? When if I plug in directly 1, I'll get 1 divided by 0, which means the limit is infinite, right? And in fact, as we're approaching positive 1 from the positive side, this difference down here is getting closer and closer to 0, but it's always positive. So because it's always positive, the form of this limit is basically of the form 1 divided by, I usually write 0 approaching from the positive side. That's the form of the limit if we're approaching 1 from the positive side, which is going to infinity. Okay, same thing here, because as we approach 1 from the positive side, of course, this factor right here will be equal to or close to 11, right, which is positive. But this one's going to 0. But again, if we're approaching 1 from the positive side, we're a little bit more than 1, and so this difference x minus 1 is positive, but again, it's getting closer and closer to 0. And so we're of this form as well. Well, I say 1 over infinity, it actually might be 11. So sorry, 1 over 0, it's actually 11 over 0, but same thing. This is going to infinity. And so this is infinity minus infinity. That's an indeterminate form. If we approach 1 from the negative side, we'll get essentially the same thing. This will be negative infinity, and this will be negative infinity, but negative infinity minus a negative infinity is negative infinity plus infinity, which is the same thing as infinity minus infinity. That is indeterminate, right? Infinity minus infinity is not necessarily 0. It could be 0, it could be infinity, it could be some finite value. So we have some work to do. What is the actual algebraic work to do? Combine these as one fraction. And so that's why I went ahead and factored this. Notice the least common denominator is going to be just this product, right? We have this common factor of x minus 1, and then we have the factor of x plus 10. There's the least common denominator, the least common multiple of these two denominators. So I'm going to take this first fraction and multiply it by what? X plus 10 in the denominator and numerator. And so here's what the support looks like. Notice I write the limit there, and I'm going to multiply top and bottom by x plus 10. So I'm going to get x plus 10 all over x minus 1 times x plus 10, right? So I multiplied by 1 here. And now I'm going to go ahead and just write this in the factored form. The denominator that we have, that's not changed at all. That's the same. But now I have the same denominator, so I can subtract, right, the numerators. So up top, I'll get x plus 10 minus 11 all over that. All right, and I can simplify the top because positive 10 minus 11 is negative 1. And then we see, right, hopefully at this point, again, I can't plug in directly because I'll get 0 over 0. So the form of this limit is indeed 0 over 0, which is still indeterminate form. But now we can simplify and get a determinate form because this common factor of x minus 1, right? I can divide numerator and denominator by x minus 1. And I'm left with the limit as x approaches 1 of just up top 1 and in the bottom x plus 10. If I plug in now directly, x is 1, I can do that and get a determinate expression, right? 1/11th, and that's the value of this limit. Okay, so that's how we handle limits of the form infinity minus infinity. Essentially what we're going to do is combine the two fractions, the two rational expressions, as one rational expression, simplify, and then hopefully we'll find that common factor to be able to then evaluate the equivalent function, right, which is continuous at 1.